So this section is about linear differential equations. A linear differential equation has this form: dy over dx plus yfx equals gx. Now you could also have the roles of x and y reversed completely. You could have dx over dy plus xfy is equal to g of y. And we don't have to mention that separately, because once you learn how to deal with this equation, then when you encounter that equation in which the roles are reversed, you just replace x and y and do the same thing. I mean, interchange x and y and do the same thing. So to find the solution of such an equation, we first find the integrating factor I, which is equal to e power the integral of f. And then the solution of the equation is y is equal to 1 over the integrating factor times this quantity, which is the integral of I times g plus c, where I is the integrating factor. So let's look at an example and see how we put this into practice. So keep this in mind. The form is dy over dx plus y times a function of x equals another function of x. Dy over dx plus y times a function of x equals another function of x. So the first equation given to us in the software was this one: dy over dx equals y over x plus 1. So remember, the form is dy over dx plus y times a function of x. So it doesn't look like linear, but it can be made into a linear one if we bring this quantity over on the left. So let's do that. So if I just bring this over to the left, it becomes negative equals. So I get dy over dx minus y over x equals x plus 1. So now this looks more like it, but still it's a little bit off, because remember the form was dy over dx plus y times a function of x. So if I want to write this as plus y times a function of x, I will write plus y, and then the function of x that is left over is negative 1 over x. So I will have y times negative 1 over x. So now it's exactly in the form of a linear equation: dy over dx plus y times this function of y times f of x. So f of x here is negative 1 over x equals, not 7, just x, equals g of x. So g of x is x plus 1. So we can say that this is linear. Linear f of x equals negative 1 over x, and g of x equals x plus 1. Okay, so remember, the solution of the equation was found by first finding the integrating factor. So let's get into the draw mode and find the integrating factor. I was e power the integral of fx. So fx is negative 1 over x equals e power. Now the integral of negative 1 over x is negative ln x. Now at this point, you don't worry about, remember, the correct integral of 1 over x is ln of absolute x, but don't worry about the absolute value at this step when you are integrating to find the integrating factor. So at this step, we neither worry about the absolute value in the log nor do we worry about the constant of integration. So just write it as e power negative ln x. And now you know that e and ln cancel out if there is nothing in between, but right now there's this negative sign in between. So we need to send this negative sign somewhere else, and the only place we can send it is in the power of this x using the log property. You know that the power over here can come as a coefficient. Similarly, the coefficient over here can be raised to the power if there's a log here. So e power ln x power negative 1. And now e and ln have nothing in between and they can cancel out. So that's 1 over x. Or we can even first write it as x power negative 1. Let's say x power negative 1. And then that's equal to 1 over x. So the integrating factor is 1 over x. So remember the solution was y is equal to 1 over I. So 1 over x times the integral of I times g. So I is 1 over x and g was the right hand side, which is x plus 1 plus c. Now 1 over x is just x, and then you distribute this 1 over x onto the x plus 1. So 1 over x times x is just 1. And then 1 over x times 1 is 1 over x. And that will be equal to x times, so the integral of 1 is just x, and the integral of 1 over x is ln x. So now you do write the absolute value, and then plus c. So this c is not part of the integration, that's just a plus c. And now this integrating factor that was outside, that distributes over all of these. So you get x squared plus x ln x plus cx. So x squared plus x ln x plus cx. X square, now first write x and then write square. X ln x plus cx. So this now instead of dy over dx, you have dx over dy. So remember I talked about this, that here you just interchange the roles of x and y. So first the derivative needs to be isolated. So we divide everything by y. So that gives us dx over dy, dx over dy equals 8x over y, or plus 8x over y, 8x over y equals 6y cube, because the 6y4 will also be divided by y. We're dividing each term by y. 6y cube. And now this is of the form dx over dy So now we should have dx over dy plus x times a function of y equals another function of y. So remember, the original form was dy over dx plus y times a function of x equals a function of x. Now, since we have dx over dy, so we should have x times a function of y equals another function of y. Now that is almost in this form, but we just can write this one as x times 8 over y. So this term can be written as x times 8 over y. X times 8 over y and now it's exactly in the linear form. X times a function of y equals another function of y. So the first function is 8 over y, and the second function is 6y cubed. So remember, the way we solve it is so let's rewrite this: dx over dy plus x times 8 over y. So draw mode, dx over dy plus x times 8 over y equals 6y cubed. So the integrating factor now will be e power whatever comes over here. So 8 over y be dy now equals e power 8 times ln y. And so again, we can cancel e and ln if there is nothing in between. So we need to raise this 8 to the power here is equal to e power ln y power 8 equals, now it's just y power 8. So the integrating factor is y power 8, and then the solution now will be, solution is, so remember when we had the x and y interchange, the solution was y is equal to, now it will be x is equal to, and you had 1 over I, that is still going to be the same. And then in the integral, you had I times g. So you will have I times g. Now it will be dy because those will all be functions of y plus c. So the roles of x and y, remember originally we had y here and we had a dx here. So we have interchanged them. Now we have an x here and a dy here. So it will be 1 over y power 8. The integral of I times y, I times g, so y power 8 times, what was the g? So g was 6y cubed. Plus c. And now, before integrating, we need to simplify it. So you can write it as 6y power 11 dy plus c. So the integral is 6y 12 by 12 plus c. And this simplifies to, so the y12 over y8 will be y to the 4, and 6 over 12 will be 1/2. So y to the 4 over 2 plus c over y power 8. So x is equal to y to the 4 over 2 plus c over y power 8. Y power 4 over 2 plus c over y power 8. Okay, so what's wrong? Y power 4 over 2 plus c over y power 8, 8x over y. So let's see, where's the mistake? 8 over y, integral, okay. Y power 8, okay. 6y cube, 6y cube. So that's 6y to the 11th. So that'd be 6y 12 over 12. Y 4 over 2 plus c over y power 8. That looks right. Let's see. Y 4 over 2 plus c over y power 8. Oh, they already have the x of y written, so I don't need to write this part. They already have the x written for us. So yeah, so I just need to write. So the x is already written by them. X is equal to, this is what it was. All right.